Brain templates. Okay, so we're talking about how the individual subject's brain scans are aligned to make them more directly comparable. Differences can be due to differences in the resolution of the scanner, the positioning within the scanner, or the subject's brain size and shape. Most of these can be accommodated for with some rotation, resizing, and shifting. This realignment is called registering, co-registering, or transforming an image. The transform part is in reference to a transformation matrix, which describes exactly how you're shifting, resizing, and rotating. One transform looks like this. The diagonals are resizing, so this is shrinking about 7% in the x and y directions and shrinking about 11% in the z direction. Around them are rotating. This is rotating in the direction of lifting your nose up. The rightmost column is shifting, also called translating. This is slightly to the left, slightly backwards, and 4 millimeters upwards. So within a single study, you can choose one subject and use it as a reference brain, or a template, and find the transform that best aligns each subject to it. You could choose the subject that would require the smallest transforms for the other subjects to match to it, or you could create a template by finding the average brain. Those methods would work fine with a single study, but it would be very difficult to compare your results to other studies since there's no guarantee that your reference brain would line up with others. This is a significant problem because it makes each neuroimaging study stand on its own. It hinders meta-analysis and data mining in the field until a better reference system is developed. The TAILORAC reference space was developed in the 80s. It provides an XYZ coordinate system in a standardized brain space by developing a registration system that aligns several anatomical landmarks in a precise way. The first landmark to find is the mid-sagittal plane, the space between the two hemispheres. The y and z axes are oriented within this space. Next, the ACPC line is found. This is a series of landmarks including the inferior point of the anterior commissure, the thalamus, the posterior commissure, and the top of the cerebellum. The AC is set to be at the origin, or 0, 0, 0 coordinate, and the ACPC line is set to be the y-axis. This also sets the x and z axes. Now that all the rotation and translation is finished, scaling is applied to fit the extremities of the brain to a standard bounding box size. Having a standard coordinate space is great, but finding the anatomical landmarks requires a lot of expertise. With some types of data, landmarks cannot be precisely found, so some template brains were developed in the 90s by the Montreal Neurological Institute at McGill University. The TAILORAC space was developed on a single subject's brain, and there was concern that it was not a representative template. So M&I made some templates out of averages of many people's brains. In 1996, SPM, an image analysis software package from University College London, distributed templates and an automated registration system. The first template, called M&I 305, defined the M&I space. It was used for a few years until SPM was updated with a new template, ICBM 152, which is still used to this day. With these average templates, anatomical differences between the subjects come out as sort of a hazy blur. So to make a high-resolution template, M&I also made an average of mini scans of a single subject, a student of theirs named Colin. This template was fit to M&I as well and distributed as the Colin brain, or Colin 27. Another software package, FSL, from the fMRI-B Center at Oxford, implemented automated registration using these templates. SPM and FSL account for a large amount of the neuroimaging analysis. M&I space has been called TAILORAC-like. The two are similar enough you could mistake one for the other, but they're different. M&I space has a larger bounding box because the averaging process made a sort of composite image, which was larger than most brains. M&I space was developed using different anatomical landmarks for registration, so the AC is 4 millimeters below origin, and the y-axis is tilted in a nose-down direction. So throughout the brain, you're likely to be a few millimeters off, up to 1 centimeter in the worst case. This is enough to have a significant effect on meta-analyses, which group data using both spaces. Side note, make sure to use Mango's world space setting if you want transforms applied. Otherwise, it will be image space, which puts the origin in the corner and isn't either of these reference spaces. Because TAILORAC and M&I reference spaces are both standardized coordinate spaces, we can develop transforms between them. The first of these is called the Brett transform, or M&I 2 tau. It was developed by Matthew Brett around 1999 for aligning the M&I 305 template to TAILORAC space. Another method was developed in 2007 by Lancaster et al. It was shown that SPM and FSL apply different transforms when registering to the same template. So 3 transforms were developed and validated, one for SPM, one for FSL, and one pooled general transform. These transform data that was registered to ICBM 152 to Taylor XBase and are called ICBM 2tau, or the Lancaster transforms. Although it's not guaranteed to line up perfectly with Taylor XBase, automatic registration using a template that has been properly registered to Taylor XBase is pretty good at aligning the AC and other landmarks. These days, manual registration is rare. A high-resolution Colin 27 template registered to Taylor XBase is available from our ginger ale website. So when you're coding a paper, pay attention to the image processing software package used, the brain template used, and any transforms applied. This topic can be tricky. Papers are often processed in M&I and reported in TaylorEC. Sometimes even paper authors get confused about which coordinate space their data is in. But the quality of our coordinate databases is at stake, as is the quality of meta-analyses using this data. If you find a paper that is confusing or contradictory, please make a note in the description so it can be carefully reviewed.